All right. Say, hi world, right? Here we come. So number one, I want to simplify this, and I notice the biggest number that goes into 20 and 14 is simply 2. Yes? So 20 divided by 2? 14 divided by 2. Next, I look at the variables. And the simple exponent rule is, if you're dividing and the bases are the same, you subtract. So 6 take away 2. And because we have more x's in the numerator, the x to the fourth goes in the numerator. Done. And that feels probably like last year or 8th grade. So let's look at number 2. Not 8th grade? Did you do that in 8th grade? No. Oh, last year? Yeah, there you go. 9th grade then. Here we go. Number 2. I want to simplify this. Step 1 is going to be, when it's not a monomial, right, is to see, is there anything factorable? So anything that can be factored, factor it. So look at the top. Is there some way to factor the top? The first thing we look at, is there a greatest common factor? What's the biggest number that goes into 6 and 36? So can you factor out a 6? And then what's left over you find by dividing. The denominator is prime. There's nothing that can be done to simplify that. Next, is there a common factor on the top and bottom that matches? And if they match, here's the rule. When you divide two things that are exactly the same, the answer is always 1. So we're not going to do this every time, but I want you to understand it didn't disappear. It became what number? No. And 6 times 1 is 6. We're not going to do that step every time, but if I don't do that step, someone was going to think that it was like some magic act that just disappeared. There's nothing left over, right? So the rule is, if it's the same thing, top and bottom, and you're dividing, the answer is always 1. And when you multiply times 1, it doesn't change the number. But there's still a 1 there. All right, let's look at number 3. Do you have the skill to simplify this? The numerator is prime. You know what that means? It's not factorable. It's already written in the simplest way. The denominator. Are you able to factor that without drawing a diamond? If you have to, you have to. We got this. Diana, what would you do to factor the denominator? What is that? Which one's positive? And which one's negative? Now, here's that example. Do you see a common factor on the top and bottom? So that means you can divide. But when you divide, does it disappear? Or what number is left over? See, what happens is when you divide, you go, okay, like this becomes your answer. Because you don't know what happened, right? It becomes a magic show rather than math. So when two things are exactly the same and you divide, what's left over is a 1. Now, if that 1 was in the denominator, is it necessary? So when you divide by 1, do you need to keep a 1 on the bottom? But if you have a 1 in the numerator, is that necessary, right? So 1 is necessary and 1 is not. All right, try number 4, and then I'll ask somebody. So you can be famous worldwide. Over 300 subscribers. This one. So let's see how we're doing. Daniela, how would you factor the numerator? Or you can ask for help.
I would multiply the 2 and the negative 1
and make it negative 80. And I think they'll feel disappointed that the first step should be, what number do they all have in common that goes into everything evenly? So my first step is to divide. And the truth is, do you really want to go through all those steps if you didn't have to, right? If there was a common factor, and then you divided, wouldn't you rather factor this of what's left over? Like, look what's inside the parentheses. Is that now a simple trinomial where it doesn't require like 3 steps to factor it? All right, I'm going to leave the denominator alone right now, but Daniela, you're going to tell me, how would you finish the numerator? The numerator, what's in that? Not the denominator, but the numerator. Now, do you see what's left over inside the parentheses? How would you factor that? Or you can ask for help. Okay, do you see negative 20? You don't see it, but what number's in front of R? So we're looking for 2 numbers that multiply to negative 20. And because 20 is negative, you're subtracting. Exactly. So we're going to have, in order doesn't matter, positive 4 and negative 5. So we need to have the ability to factor. And once everything is factored, it's easy. Then you're matching and dividing out. Okay? Let's look at the denominator. Kaylin, how would you factor the denominator out? You'd factor out an 8. And what's left over? So I'm going to write that over again. Kaylin, do you see any factors that match that can divide out? What do you see? Now, when I go r plus 4 divided by r plus 4, does it vanish? Or what number's left behind? Now, when I multiply by 1, it's not going to change anything. So I don't need the 1 there, but I need to know it's there if I need it. There's something else that simplifies. So 2 goes into 8 how many times? So the whole answer, written in simplest form, what am I left with here? So remember when I divide out, what number don't you see that's there, right? So when you divide, it's not like the 2 is gone, right? It becomes 1. And so 1 times r subtract 5. And then what's left in the denominator is just 4. Awesome. Good job. Number 5. I'll give you a moment, then I'll call on somebody. Who knows? And I get that sometimes you're tired or not in a good mood to learn, and that when we make a video together, when you are ready this weekend, right, you can watch it again if you want to. Okay? Thomas. Can I tell you something, Thomas? You know, I don't know if you know, I have 1 son, right? 3 daughters. And my 1 son, his middle name, I kid you not, is Thomas. I know. It's true. So, maybe there's something there where I want you to be your best, right? And everything, right? So, number 5. Can you help me factor out the numerator? Or you can ask for help. I like that. So what should I write down?
E squared. Or no, you just put the negative 5.
You keep talking out loud. I like how you're thinking through it. Once you come to the end of your thought, tell me what I should write down, what the factors are. So keep thinking. And if you want, I'll support you. See, it's a dramatic pause for the video.
Yeah, can you help me?
Sure. This is called a difference of squares. To do a difference of squares, you square root each term. And the square root of p squared is p, and the square root of 49 is. And so you're gonna, one is going to be adding, and the other is going to be subtracting. Go ahead, and you're looking at it like you've never done that, and I don't think that's true. So it's a difference of squares. You square root each term. One's adding, one's subtracting. Totally not complicated. You just have to feel like you're awake enough to just do it. You've done that before. I know. All right. Alyssa. Ah, you think I'd never call, right? Sometimes. So, can you see anything that divides out? Say that again so I can hear it. So, I am going to divide P subtract 7 and 7 subtract P. Oh, there's like mumbling and grumbling over here. The peanut gallery here. You know what they're mumbling about? I'm going to tell you. Someone says wrong and they don't know what they're talking about. But I'm going to tell you why they're mumbling and grumbling. That P, are you going to let me? P subtract 7 does not match 7 subtract P. They're different, right? But let's hold that thought. First thought is, if it was adding P plus 7 and 7 plus P, they would match because it doesn't matter what order you're adding, right? When you're subtracting, order matters. So the first thought is, yep, they don't match. But here's your next thought. Are they exact opposites? And do you know what I mean by the word exact opposites? One is negative 7. What's the other one? Positive 7. One is positive P. What's the other one? Do you see how they're exact opposites? These are called opposite factors. Have you ever heard of that before? Opposite factors, think with me, when you divide them, they don't equal 1. Opposite factors, when you divide them, equal negative 1. Were you going to do that? Now you know, right? Cool, right? So this is the whole idea that it's not a magic show. We're not like doing this, let's just cross them out and it disappears. Is that math? Got it? Do you know that some, when they do this, they just enjoy crossing things out? And it's like a magic act. Like you cross it out, it disappears, what's left over is your answer. So we're dividing, and when we're dividing opposite factors, what number's left over? So the answer is P plus 7 times what? Can you distribute and tell me the answer? Excellent. Did we all learn something there? So could we divide those out? Is it okay that we did that? Yes. But what did we have to understand? That they are what type of factors? Hey, do you see this little box that says, watch out? So A subtract B and B subtract A are called what type of factors? Opposite factors, and they divide to equal negative 1. So if they match exactly, then what happens? They divide to equal 1, I'll say it. If they're opposite factors, they divide to equal A. We're on this. Number 6. Thank you, Alyssa. Let's do this. Miss Evelyn. Now the world will know you. Tell me, the numerator, how would you factor it? Put out. We're going to use a math word. What math word do you think I want you to say instead of put out? That's the math words. Factor out. And you could do negative 3a. This is what I'm aware of. Which one of these terms is the power term? A cubed or A? And what I want usually is I want the power term to stay positive. So if I factor out a negative number, it's going to make the first term negative when you divide. So instead of a negative number, I'm just going to factor out a positive 3a and now divide to know what's left over. So after you factor out a 3a, what's left over?
4a squared minus 1.
Excellent. All right, we're going to look at the denominator. Claudia, can you tell me how to factor the denominator? Take out. It's like we're doing Chinese food. But in math, you ever do Chinese takeout? Yummy. But in math, we're not going to say take out, we're going to say factor out. So what are we going to factor out? The what? 6a squared. You know what that's called? The greatest common factor. What's left over when you factor out a 6a squared? 2a and? Excellent. Pedro. What do I do next? What am I going to divide?
3a and 6.
Okay. what do I left over with when I divide 3a divided by 6a squared?
1 is the numerator. Great. So, 1.
So when I divide, the number left in the numerator is 1. I'm not going to put a 1 there, but it's there. It's not magic. Didn't disappear. And so the only thing left on in the numerator is, because 1 times that is 4a squared, take away 1. How about the denominator?
2a. 2a parentheses 2a plus 1.
Now, I'm going to do a step just to show you something. You ready? You wouldn't normally do this, but I want to teach you something that happens. 2a times 2a is 4a squared, and 2a times 1 is 2a. Now, I wouldn't normally do this, but it's a great example of when someone makes a mistake, could make a mistake. And do you know what algebra mistake someone could do here? They would see 4a squared, and they would see 4a squared, and what would they be tempted to do? Do you know why that's bad algebra? Because you're not dividing. See, the only way we can divide something if it's multiplying. Do you see these parentheses on the top and bottom? That means we're multiplying, so we can divide, right, in what's happening. But what's here? Do you see anything that in terms of multiplying? When you see adding or subtracting, can I then divide out? And so I want to make sure that you don't make that mistake. The only way 4a squared subtract 1 divides out if there's another 4a squared subtract 1. They have to match exactly. You can't take half a binomial and go, yeah, I'm just going to divide the first half out. Okay? So I know that there'd be a temptation, correct? To cross out the 4a squares? So we're only going to do that when we see parentheses and we can see the whole factor removes, not half of it. All right, let's look at number 7. This is the answer. This was a learning moment. Are we good? All right, let's look at number 7. Mr. Richard, you ready? I want you to look at the numerator, Richard, and I want you to factor it. So the step 1 is there's a common factor in the numerator, which is 2. So when I divide out a 2, what's left over?
3n squared plus 4n plus 1.
So 3n squared plus 4n plus 1. Just for fun, we're going to factor out the denominator and factor out a 2 as well. What would be left over?
N squared minus 1.
All right. Richard, how do I factor what's left inside the parentheses on top? What would you do? And I'm going to do it in the margin and then come back to the question.
Multiply the 3 and 1.
Correct? So 3 times 1 is 3, and 3 plus 1 is 4. Then, on the side, because I'll come back to the question, I'm going to write 3n squared, but I'm going to take out 4n. What's going to be in it? So, take out, substitute out 4n, and what are you going to put in? 3n and 1n, and we still have a 1 at the end. So, how would I do that?
Factor out the 3n.
So 3n, and what's left over?
N plus 1.
The next two, what do they have in common?
So we factor.
So if it's prime, what's the only number that goes into it evenly?
1.
That 1 is necessary, or else you won't get the other factor. And then you have n plus 1. So what am I left with then? I'm going to come back to the question now.
3n plus 1.
I got 3n plus 1. What's the other one?
N plus 1.
And Richard, do you see the denominator? N squared take away 1. Thomas has already learned this, or I go back to Thomas. What type of factoring is n squared take away 1? Oh, do we know how to do that now? So the square root of n squared and the square root of 1. So n plus 1 and n. All right, now the fun part. Now it's the matching part, right? And when we're matching, we're dividing, and the number left over is 1. unless they're opposite factors. Tell me a factor that matches, I can divide out.
N plus 1.
So n plus 1 divides out and leaves you with a 1. Again, I don't need to put the 1 there because times 1 doesn't change anything. If everything divided out, I got to make sure I know what's left over. Keep going, Richard. What else divides out? He says the number is hitting you in the nose, I swear. Right there. What else divides out? The 2. So 2 divides out, n plus 1 divides out. So what's our final answer? What's left in the numerator?
3n plus 1. Oh, no, n over n minus 1.
Awesome. Done. Let's look at number 8 together. Nicholas, how would you factor out the numerator for number 8? How would you factor the numerator?
I would factor of 5.
And then what would you be left with?
9 and negative 2.
And now the denominator. I'm going to I might run out of space. We'll see. How do I factor out the denominator?
I would do a diamond.
And what's 3 times 9?
27.
And then negative 28. What two numbers do you think we're going to use?
Negative 27 and negative 1.
So negative 27 and negative w, they add up to negative 28 and they multiply to 27. So I'm just going to do this on the side. So my question's still on the right side. So how would I factor this? Keep going.
I would take out a 3w.
You're not doing Chinese takeout.
I would factor
Yes.
3w out of the first two.
And what would be left with?
A w to negative 9.
And the next two?
I would just take out negative 1.
You would take out again. You're going back to doing the Chinese takeout.
I would factor negative,
Factor out.
and then I'll be left with w to negative 9.
All right, we're done, right? So let's go back here. I have 5, 9, subtract w. Now, what's in the denominator? Can you do the last step and just put it in the denominator? What would it be?
3w negative 1.
3w, take away 1, and...
W negative 9.
All right. I'll give you a moment. I want to make sure you understand what's going to happen next, right? Do you see any factors that divide out? What factors do you see that divide out?
Oh,
Do you? So I want you to notice this. That n, 9 subtract w, and w subtract 9, there's a name for them. They're called opposite factors. And when you divide out an opposite factor, the number that's left over is negative 1. So the answer is negative 5, 3w take away 1. You are awesome sauce, Chris. Turn the page. All right. Next, we're almost done. We're going to do some examples. So the first thing was, do you know how to simplify a rational? And what did we basically do? We factored, divided out common factors, and what's left over is left over, right? If you can't factor, you can't do rationals. So, practice, right? How many days have we factored in questions so far, right? It's been week after week, right? So the more we practice, the more confidence, the better we get. Multiplying. If I'm going to multiply rationals together, I need to know the rule. What's the rule? So I'm going to show you a fraction, and I want to know, hey, what's the rule What's the rule to multiplying fractions?
The denominator needs to be the same.
Do you think that's the rule to multiplying fractions? Do the denominators need to be the same? But I like you had confidence, right? So, do the denominators need to be the same? Not the rule. We are going to do that rule, but that will be on Monday. So, the rule for today is, when you're multiplying, it's a very simple rule. So let it be rule, right? The rule is you multiply the numerators and that's it. Now, the only little hook is this. It's usually nice to simplify before you multiply. In other words, does 2 go into 4 evenly?
Yes.
How many times? And what's left over here? And is there anything else on top that can simplify with what's on the bottom? No, right? And notice it doesn't have to be a part of the same fraction, right? You can take the top of one and the bottom of the other, and then when I multiply, you get 3 over 16. So our technique is going to be simplify and then multiply. And when we multiply, you know the mistake people make for the rule? Is they think that they're going to do what? Cross multiply. Are we doing that?
No.
So we multiply the tops and the bottoms. None of this. Yes?
Yes.
Okay. Let's start. So in number 9, I first want to simplify. I'll do the first one. Anything on top can simplify with anything on the bottom. So if I say, hey, 2 goes into 6, how many times? You can do that. I'm going to kind of make sure that 9 doesn't feel like a part of the problem. If I said, hey, I see another one. You ready? 3 goes into 18, how many times? And we know when we divide out, what's left over is really a 1, right, afterwards? And there's one more thing. How about 10 and 6? So, not evenly, but the number that goes into both is 2. So the 10 is 5, and the 6 becomes a 3. So already for my answer, what do I know will be the coefficient on top? And what do I know will be the coefficient on the bottom? Now we need to know exponent rules. You ready? When you multiply, you add exponents. What do you do when you multiply? What do you do? Add. When you divide, you subtract. So let's try again. When you multiply, what do you do with the exponents? And when you divide, you... And the only big rule is the bases have to be the same, so the x's will be with x's and y's with y's. So we're going to do this in one step. You ready? How many x's do I have on top? And you're just adding. Say 5. How many x's do we have on the bottom?
2.
How many x's?
2.
So what's 5 take away 2?
3.
Got it?
Yes.
How about the y's? How many y's are on top?
7.
How many are on the bottom?
4.
So 7 take away 4?
3.
Can these divide out? Because they don't have the same base. All right, let's try it again. Hey, ask me. I'm good at answering questions. Bro, yes, tell me. Did I put the y on the bottom? That's just silliness. So, do you notice that we have more y's on top? So when we subtract, the y should stay on the top. What do we do again? 7 take away 4, which is 3. Thank you, Kaylin. You saved me. Number 10. So the only thing in the denominator is 3. So let's try again. Are you able to look at the coefficients and simplify them? Let's try. K. What do you notice about the coefficients, the big numbers?
You can...
K. I said K. Yes, K. So 4 goes into 12. Keep going, K. 3. Does anything else simplify? So 5 goes into 15. Now, what's left here that you don't see is a 1, just to remind you of it. But 1 times 1 is 1. I'm not going to put that there, because there's probably going to be variables on top. But 3 times 3 is 9. If all the variables simplified on top, then you would have to have a 1, right, if that's the case. Let's look at the A's. Michael, how many A's do I have on top?
5.
And how many on the bottom?
5.
Correct. So when you don't see an exponent, the exponent you don't see is 1. That means all the A's divide out. Done. Right? They match? They're done. I'm left with the number 1. B's. Genesis, how many B's do I have?
8,
And how many on the denominator?
10,
So, how many more do I have in the denominator?
2.
Got it? Subtracting. And we have more in the denominator. That's why it stays in the denominator. Remember I went back to, hey, what number needs to be here? Right? So everything divided out of the top. So what number is still left over? 1. All right, number 11. Before I multiply, I'm going to simplify. And to simplify, I need a factor. Before I multiply, I'm going to simplify. And before I simplify, I need to factor. Kim, how do I factor number 11? Take the first numerator.
The factor of 4x,
And what's left over?
x minus 1.
Keep going. Let's do the next numerator. So the next numerator.
You're going to do the diamond.
Okay, go ahead. I'm not going to do it. It's, the numbers are so small. You're just going to tell me the two numbers that factor it.
3 and 6.
Good. Which one's positive?
3.
And that makes 2 negative. Is that right?
Yeah.
So positive 3 and negative 2, and they add up to positive 1?
Yeah.
Excellent. Now the denominator. All right, Jessica, how do I factor the first denominator?
You multiply negative 6 and 2.
So you know what I'm going to say that we're going to do first. I'm going to factor out a 2. I always look, is there a number that goes into everything evenly? What is it? Do you know why I do that? Because now what's left in the parentheses is a simple trinomial. And that just made my life quicker, easier, right? More efficient. So now tell me the factors of the denominator.
Negative 1 and 3.
And don't forget the negative 1 and 3, and don't forget the 2 in front, right?
Yeah.
All right, Jessica, how about the second one? Can you factor it?
Take out of 4. X.
Take out. We're back to, right?
Factor.
Factor out. Okay. What are we factoring out?
4x.
And what's left over when you factor out 4x?
X plus 2.
All right, now we have to match. All right, Sarah, do you find any factors that divide out?
X plus 3.
Any other ones?
4x.
Any other ones?
Either x minus 2 and x plus 2.
Good question. So I'm going to let you think. So the first thing is, they obviously, one's adding, one's subtracting, right?
Yeah.
So are you thinking they could be opposite factors? Good. So I want you to think through that. If they are opposites, instead of positive x, it would be negative x. Instead of negative 2, it would be positive 2. So both terms are opposite. Is that the true here or not true? Not true. Are they opposite factors? No. If they were opposite factors, one would be positive x and one would be negative x, right? So it's not just the number, the variable also, right, are opposites. So they do not. There is something else.
Oh, x minus 1.
Oh, x subtract 1 is there, right? I don't see anything else. So what would your final answer be then? What's left after all of that? Remember, there's what numbers here? So 1 times x minus 2?
It would be x minus 2 over 2 times 3 is x plus 2.
Excellent. Even though there's a bunch of 2's there, they do not divide out. All All right, one more to do with multiplying.
Simplify the 2 parentheses x plus 2.
So, you mean, do I distribute?
Yeah.
Not necessary. So, the work we're doing today, you can leave it, as long as it's prime, you can leave it in factored form. So, as long as there's nothing that divides out, you can leave parentheses in your answer. Okay?
If you want to, or you have to?
If you want to. You don't have to distribute. Okay? All right, number 12. We're almost there. Eduardo,
Yeah.
how do I factor the numerator? Or you can ask for support.
You can complete the square, right?
No. I like the words complete the square, and it sounds mathematical. But in this case, we're just taking out a common factor. So factor out a factor, right? What do they have in common? 10 and 5.
5v,
5v. And then what's left over?
2 minus v.
Excellent. That makes me feel there's going to be a common factor, but we'll see. I mean, an opposite factor. Let's keep going, Eduardo. The denominator. What two numbers multiply to 18 and add to negative 11? Two numbers multiply to 18, Eduardo, and add to negative 11. What would that be? Two numbers multiply to 18 and add to a negative 11.
9 and 2.
Good. And both are negative. Is that right? All right, you're on a roll, Paw Patrol. Look at the top. Two numbers that multiply to negative 9 and add to negative 8.
Negative 9 and positive 9.
Good. And 15v is what it is. Now we're going to start matching and dividing out. Aaliyah, tell me something that matches that I can divide out. V subtract 9 divides out, and it leaves you with 1. I don't need to put it there.
And then the 2v and v2 will be with negative 1.
So 2 subtract v and v subtract 2 are opposite factors, which means I'm left with negative 1. Excellent. There's something else left.
I mean,
So 5v and 15v, right? So 5 goes into 15, and the v's divide out. So we have one fraction. So now what's left for the numerator, and what's left for the denominator?
negative 1 and v plus 1.
So negative 1 and it's okay to write it like that. You could also write it as negative v, take away 1. Both are great. And what's left in the denominator?
3v.
There's no v, right? That v divided out. So the only thing left in the denominator is a 3. Perfect. Hey, what goes with multiplying? Dividing. Corey, did you look at your phone because you want to know what the time was? There's a big clock right there on the wall. You didn't even have to flip your phone up. So, number 13, we still have plenty of time to do 4 questions. You ready, Corey? What's the rule to dividing fractions? So, no, that's not it. So, I want you to look. Shh. If I was dividing fractions, what's the rule? Because then we can go to algebra and be able to understand it that way. Go ahead, Corey. What's the rule? 3/4 divided by 5. I know. Look at that. You're stretching. You know it, right? The rule? You're stretching? All right. I bet she does. Huh?
You flip the second fraction and change the sign to a multiplication.
I like it. So you're telling me I should change it to multiplying, and I do that by taking the reciprocal of the second fraction, right? This is really your divisor, and this is your dividend, if we want to use those words. So it's the reciprocal of the divisor, right? Which is really the denominator, right, in terms of it. You do the reciprocal. And then you would simplify, correct? And then you would multiply. So multiplying and dividing are exactly the same, except step 1, the reciprocal. Got it? Let's do this. Marilyn, you ready? Are we good? All right. Are you trying to like, oh my gosh, Friday morning, I'm kind of like a lot of work, I'm a little tired? Got it. So, step one is to understand, and those are P's and Q's, right? So, I need to understand that when you are dividing, you're really multiplying times the reciprocal. So I'm going to write this as 8q to the 5, 35 p squared q squared. Now these are monomials. So I'm not going to factor first. I'm just going to look, and I'm just going to divide out what I see. So do you see anything that simplifies here? So 5 goes into 35, 7. Perfect. Keep going. So 8 goes into 16 twice. Remember, the number that we don't see on top is 1 if we need it. Keep going. How many p's do I have on top? How many p's are left on top? 1 p, right? Yes?
Yes.
Yeah, 1 p. How many p's are on the bottom? 3 and another 2. How many p's? So 1 p on top, 5 p's on the bottom. How many more p's on the bottom? 4. So 2 times 7 is 14. That goes in the denominator. And you just said there's 4 more p's in the denominator. Let's look at the q. Marilyn, how many q's are on top? How many q's? You said 5? And there's still 1 here, so 5 plus 1 is 6. How many q's are in the denominator? So 6 take away 2. How many more q's in the numerator? Done. So the answer is q to the 4th over 14p to the 4th. 14. 3 left. Can you divide rationals? Here we go. Jocelyn. Number 14. I haven't said Rosie, I haven't said Jocelyn, I haven't said Clarissa. That sounds like 3 questions. So, Jocelyn.
Yes.
Help me with number 14. Step 1.
Factor out.
No.
No. Oh,
Step 1.
that's the sign.
And you know what we flip the what?
That's the denominator and numerator.
Sure. So you're going to do the reciprocal of the divisor, right?
Yeah.
Have you heard the word reciprocal before?
Yeah.
Okay, cool. Jocelyn. No, Rosie's going to have her turn. Clarissa's going to have her turn. Jocelyn, here we go.
Yeah.
What do I do next?
Oh, now factor out 4 from 4x minus 8.
I like that. So it's what's left over.
X minus 2.
Okay, next. Do you know how to factor x squared plus x, take away 6?
Yeah, it'd be negative 6 and then 1. So
The problem with negative 6 and 1 is they don't subtract to equal 1. Because 6 is negative, you're subtracting to equal 1. So what two numbers multiply to 6? And subtract to equal 1. And it's not 6 and 1.
3 and 6.
Yeah. Which one needs to be positive?
3.
So 3 and negative 2, they multiply to negative 6 and add to 1. How about the denominator?
You can factor out a 2 from that.
And
2x.
and what are we left with?
X minus 2.
X plus 6 divided by 2 is?
Oh, 3.
3. Last step, Jocelyn. Tell me anything that matches.
X plus 3.
They divide out. I'm listening. Anything else that matches?
No.
It can be the bottom of the other and the top of the other.
Oh, okay, then X minus 2.
What else?
That's it.
2 goes into 10.
5 times.
Now, what am I left with after all of that beautiful dividing out? What's left that I didn't divide out?
4 in the net.
So what's left in the numerator?
5.
There it is. What's left in the denominator?
4x.
4 and x. Perfect. So the whole answer is just 5 over 4x. All right. As I promised, Rosie. Number 15.
You
So I'm going to do the reciprocal. Is that right? So let me write this out. The first fraction, which is called the dividend, I'm just going to write it over again. But the second one, I'm going to do the reciprocal. If I need to do at work, and I won't, I could do it in the margin. But the next step after this is to know how to factor. Are we a good factorer, Rosie? I think I made up a word. A factorer. A factorer factors. So, can you factor? You have 4 things to factor. Go.
The first one you factor at 2a squared,
And?
and you're left with a minus 6.
Brilliant. Keep going.
The next numerator you factor out a squared.
Are we looking at the second, like the numerator up here?
Yeah. Oh,
So it's a trinomial.
you flip it.
We did the reciprocal. You told me to.
I know.
Okay. Keep going. Communicate to me. Keep factoring. Which one are you looking at?
The next numerator.
Okay, how do I factor it? It's a simple trinomial. What 2 numbers multiply to 15? Add to negative 8. 15, negative 8.
5 and
Negative 5 and negative 3. Keep going. I need the denominators.
the next one is negative 6 and negative 2.
Negative 6 and
Positive.
positive 2. Okay, last one.
You take out a squared.
And what am I left with?
That is 3 minus
Oh, that's right. It's a 3, isn't it? 3 minus a. All right, last step, Rosie. This is the fun one. You did all the hard work, so now you get to have the fun. What do I get to match and cross out?
you cross out a minus 6. 3 minus a is a minus 3. And that goes into the fifth one.
So that's called opposite factors, right? Anything else?
And then you cross out a squared.
I like that. A squared divides out. Anything else?
And then the 2 turns into a 1 and the 8 turns into a 1.
Brilliant. Let's finish this. What's the final answer, Rosie? Then I get to hear Clarissa.
It's
What's left in the numerator that I did not cross through?
negative 8 plus 5.
So we have a subtract 5, and you're right, there's a negative 1, right? We could distribute, but not necessary. What's left in the denominator I didn't strike out?
It's 4 and then 8 plus 2.
And that's it. Brilliant. Brilliant. We have one more left.
That's so close.
Yeah, we're cheering her on. Here we go. What's wrong? Why did you throw your hands up? All right, here we go. This is our last one together, right? This will be uploaded this morning, so you can hear it, okay? So, Clarissa, shh. Do you want support because you see it looks a little different? So I'm going to help you through it. Are you going to listen to me?
Yes.
So, step 1 is that when I see dividing, I'm going to do the reciprocal. So do you see dividing? What's the reciprocal? And you say, I don't see a fraction. So what's in the denominator that you don't see? So when I do the reciprocal, 1 is in the numerator, and 4k plus 1 is in the denominator. Yay? The next one, that dot means multiplying, so I keep it the way it looks. So the step 1 is to change everything to multiplying. And if I have to do a reciprocal, I do. Okay, is that okay for step 1? Okay, next step is factoring. K plus 3 and K are prime. 1 and 4K plus 1, prime. Let's get to the one I can factor. Clarissa, how do I factor 16K squared? Take away 1.
This is
Yes. What's the square root of 16?
4k minus 1 and 4k plus 7.
Excellent. I'll write that down. And then in the denominator is k plus 3. Clarissa, any factor in the denominator can strike out a factor in any numerator. They don't have to be in the same fraction. So go. Tell me a factor I can strike out.
K plus 3.
Done. Strike out.
4k plus 1.
Strike out. Anything else?
No.
So what I'm left with on top is 1 times 4k take away 1. So what's left in the numerator? 4k take away 1. What's left in the numerator that I did not strike out?
Okay.
I just taught you a lesson on rationals. A rational is the ratio of two polynomials. Shh. A rational means fraction. A rational means dividing. We simplified, we multiplied, we divided. We factored, we found common factors, and now there'll be a quiz on Monday on this. The last page is your practice sheet. If you want to practice with me to learn this skill, there'll be a video today on that skill before I leave today that you can practice with me. Is that cool? All right, Mr. G Math.
Over now.